Alright everybody, here are the video notes for lesson 1.8, picking up kind of where we left off in class and then into the day 2 stuff. We see a problem where again we are doing combining functions here with multiplication and then division. I think it's a good problem because it shows us, especially in part B, fraction divided by a fraction. So let's start here though with the multiplication. We have 1 over x multiplying 1 over x squared. We're multiplying fractions, so tops multiply top. Bottom multiplies bottom. You end up with 1 over x times x squared is x cubed, and you have your answer. Quick and easy. Okay. More importantly, here's part B. So you have f of x is 1 over x getting divided by 1 over x squared. This is a situation where I do keep, change, flip, which means keep the numerator, change the division to multiplication, and then flip the denominator. After you do that, you'll end up having 1 over x times x squared over 1. That's the flip, change and flip. And then multiplying top and bottom, you end up with x squared over x, which reduces down to just x. Because you're going to have, or I could say x over 1, because that x is going to cancel with one of the x's on top. And then you end up, which is the same thing as x. Okay, so a nice just refresher of keep, change, flip. And then now I want to get into the day 2 stuff. So we have combinations of functions still, but these are what we call composite functions. So it's read f composed with g. I always say f of g, or the other way around I would say g of f. So like g composed of, f composed of, all right? And let's just see how these are done. Again, the video notes, the written notes are always posted, and so I just like to go through examples here. First one here is we have g of f evaluated at -2. And so the way I see it is first we want to say, well, what is f of -2? And so we do that. We do f of -2, and that gives me -2 plus 2, which equals 0. Now we're going to compose g, because this is g of f of 2, we're going to compose g of our 0 here. And so we do g of 0, because 0 is what we got with evaluating f of 2. And we can plug that in, and we get 4 minus 0 squared. Again, that 0 is coming from right here. When we calculate this out, 0 squared is 0, so this just becomes 4 as our answer. Okay, next one, we have f composed of g, or f of g of x. And so again, we want to look at what g of x is. And g of x equals 4 minus x squared. And so we're going to compose f of that. So this is going to be f of 4 minus x squared, because now it's composed of g. And so we plug that in for all the x values here in f of x, and that becomes 4 minus x squared plus 2. All right, and we can take that one step further, and that becomes, combining our like terms, -x squared plus 6. That is f composed of g of x. Okay, now we have g composed of f of x, and so we have f of x. F of x is equal to x plus 2, I believe, yep. X plus 2. And then we got g composed of that thing. And so that's g composed of x plus 2. And so we then plug for all our x values in g of x, we replace that with x plus 2. So we end up having 4 minus x plus 2 squared. Because I have x squared in my original, we're replacing x with that f of x function. And if we work that out, we end up having, I'm going to erase that and give myself a little more space. I have to FOIL that, or use the box method for that. And what that becomes is x squared. Should keep the negative on the, actually I'll do it like this. 4 minus x squared plus 4x plus 4. Distribute my negative in now. So this is 4 minus x squared minus 4x minus 4. My 4's are going to cancel, and I am just left with negative x squared minus 4x, and that would be my answer there. We will do a couple more here. So this is g of 3, whatever g of 3, negative 3 is, that's what we're going to compose f of, and so we plug in negative 3 into our g of x. So g of negative 3 gives me 5 minus a negative 3, which is 5 minus a negative 3 gives me 8. So then we're going to compose f of 8, coming from down here, and that gives me 3 times 8 plus 5, which equals 3 times 8 is 24, 24 plus 5 is 29, and that would be my answer. Okay, then we have f composed of g of x. Again, g of x is equal to 5 minus x, and so that's what we're going to compose f of x with. So it's f of 5 minus x, which equals 3 times 5 minus x plus 5. We're again replacing x up here with my function, g function, and that is distributing in. That's going to give me negative 3x plus 15 plus 5, which gives me negative 3x plus 20 as my answer there. G of x g of f of x, so we're composing g of f of x. F of x is 3x plus 5. G of x then is going to be composed of that, so it's g of 3x plus 5, which is 5 minus 3x plus 5, which distribute my negative into both. That is 5 minus 3x minus 5. The 5's will cancel, and I'm just left with negative 3x as my composite function there. Okay. Again, this is a similar problem to find domain, however, now. And so g of x, whatever g of x is what we're going to build f off of. And g of x is the square root of 9 minus x squared. So it's going to be f of the square root of 9 minus x squared, which equals, after I replace my x here, that's going to be the square root of 9 minus x squared, that whole quantity squared, minus 9. That's getting squared, gets rid of the square root, so the square root cancels the squaring, and you get 9 minus x squared minus 9. The 9's will cancel, and you're left with just negative x squared. And that there is my composite function. But we also want to look for the domain, and I talked about that a little bit in class on Friday, where we don't want to reduce things down first before we want to do domain first before we start reducing, and I kind of went against my own rule there because I didn't do the domain first. And so again, if we look at this function, it was the square root of 9 minus x squared minus 9. The only area this is going to have domain issues is with that square root there. Okay, so we need to say anything under that square root we can't have in our domain. Or like that square root can't be anything less than 0. And so what I say is that 9 minus x squared has to be greater than or equal to, this time, 0. Because I can have 0 under that square root, but I just can't have anything less than that. And so I subtract 9 over, and I get negative x squared is greater than or equal to negative 9. I divide both sides by negative 1. And I get x squared greater than or equal to, oops, that flips the sign. I divide it by a negative 1. Less than or equal to 9. Square rooting both sides. This is what I did in class. It was kind of confusing. When I square root both sides, I end up with x, and I get a positive 3, because the square root of 9 is going to give me plus or minus 3. The positive side of 3 keeps the sign the same, so that's x less than or equal to positive 3. And the negative side of things is going to make it flip, so that's x greater than or equal to negative 3. And that's going to be my domain there. Okay. If you want further explanation, I know I went through that quickly, please email me. I would love to talk more about those kind of problems. Okay, last one here. This one here has a lot of moving parts, and I'm going to go through it kind of quickly. So just be sure if you're confused as I worked this last one and you want to see it slower, more steps taken, slow, like I said, slower, just make sure you email me and say, can you do that one again? Okay, but I'm going to do it quickly here just so it's in this video. Okay, so I need n composed of t of t. And so what I'm going to do is I'm going to plug this 4t plus 2 into all my t values in n of t. And so what I end up having is 20, plugging in for my big t's now. I have 4t plus 2 squared, because I'm replacing t squared with, or I'm replacing the t in t squared with 4t plus 2, minus 80t, but that t is getting replaced with 4t plus 2, t plus 2, and then that's going to then be plus 500. Sorry for this is taking up so much room already. 20, and then I got to use the box method or foiling here. And if I do that, I end up having 16t squared, 4t, or 8t plus 8t, so 16t plus 4, minus, distribute the negative 80 in, 80 times 4t, negative 80 times 4t is going to be negative 320t minus 160 plus 500. And I need my calculator here. I got to distribute in my 20 to each of these as well. And when I do that, I get 20 times 16. That's going to be 320t squared plus 320t plus 80 minus 320t minus 160 plus 500. My 320t is going to cancel with this 320t here. 80 plus 80 minus 160 plus 500, that's going to give me 80 plus 500 minus 160 is going to give me 420. So 320t squared plus 420. And I believe that is the last thing I can do. So that would be my composite function, n composed of t of t. Okay. Now the next part here, I'm going to clear my ink, but I'm going to erase a lot here so I have room to work again. And I just want to save my equation, which is 320t squared plus 420. And then the rest I want to get rid of because I just want the room to work. And what I'm going to do is I'm going to take my composite function, and I want to find the time, so I'm going to end up trying to solve for t here, time, when the bacteria reaches 2,000. And so I'm going to set 2,000 as the bacteria, and that's going to be equal to my function, 320t squared plus 420. And I'm going to solve for t. First subtracting 420 on both sides, so 2,000 minus 420 gives me 1,580. Equaling 320t squared. Dividing both sides by 320, I get that this is dividing. I end up getting that I get 4.94 when I round it, equals t squared. Square rooting both sides. Square root of 4.94 gives me 2.22 seconds. So 2.22 seconds is my time it takes to hit 2,000 bacteria. Again, working in a small time constraint here, that's the problem. I wanted to put it in here. But again, please reach out and say like, hey, can you do that problem again, but slower, if you want to see it actually worked out with each and every step. All right, here is quickly the homework for the rest of Chapter 8. And if you have questions on any of it, please let me know.